Gonna be looking at average rate of change. Average rate of change is just a fancy way of saying slope, like average rate of change. You want to know the slope between 2 points. So we're going to be finding the slope, and we're going to use the slope formula, which is y2 minus y1 over x2 minus x1. So even if it's just saying what's the average rate of change, it's really just asking what's the slope between these 2 points. Rise over run, two R words, rise over run, rise over run, got those Y's on top. And the first question up top says, what's the average rate of change of x over the interval -2 to 0? So we're going to be looking at 2 points. We're going to be looking from when x equals -2 to when x equals 0 right there. So I have 2 points. I've got -2, 8, and I've got 0, 4. So that -2 is going to be my x1. You can't really see it. That's going to be my y1. This is going to be my x2, and that's going to be my y2. And so slope, average rate of change, slope, we normally say that's m, y equals mx plus b. M is the slope. So m, average rate of change, is going to be 4 minus 8 over 0 minus -2. More than likely, you're just going to be able to punch that in your calculator. But that'd be -4 up top divided by +2. I think that your slope between those 2 points, or your average rate of change between those 2 points, would be -2. Now, if you were, looking to graph that, whatever, that's not rise over run format, so that'd be -2 over 1. You'd have a negative slope going down the hill, go down 2 over 1, down 2 over 1, down 2 over 1. But it's just asking for the rate of change. We're going to write -2. That's the slope. Average rate of change of x over the interval -1 to 2. Let's see if I can change colors right here. From -1, when x is -1, to when x is 2. So I got rise over run. I've got my average rate of change or slope is going to be 8 minus 5 over 2 minus -1. This f of x, that's just like y. So I've got 3 over 3. That's just 1. And you could punch all that in your calculator right there, and it would give you 1. And is this function linear at the bottom? It says, is this function linear? No, it's not linear. If it was linear, then all of these would have the same average rate of change. They'd all have the same slope. We go up 2 over 1 or up 3 over 1, or, like this would be up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Well, up here we were going down 2 over 1, down 2 over 1. Like the slope or average rate of change between these 2 points is not the same between these two on the bottom down here. So is this function linear? No. This function actually looks like it's going to be quadratic. And the reason I'd say that is because it looks like this is my mirror right here, my vertex, because I've got the same thing going on each side. It's going to be an even function either way, but it's looking like it's going to be some sort of quadratic function. Next one, average rate of change. You probably push pause. Try this one. Average rate of change of x over the interval from 3 to 5. So when x is 3 to when x is 5, I'm going to use those points to find my slope or my average rate of change. That would be 4 minus 0 over 5 minus 3. I think that would just give me 2 as my average rate of change, or 2 over 1 if it's in some sort of graphing format with rise over run. Average rate of change of x over the interval 2 to 5. So I'm looking at 2, and then I'm looking at 5 right there. So I've got my average rate of change is going to be 4 minus 1 over 5 minus 2, and I think that's going to be 1. 3 over 3 would be 1. Is this linear? No, it's not going to be linear. Once again, I think it's going to be quadratic. At least it's going to be an even function. So like that is my vertex, and I've got some sort of mirror going on both sides of that thing. Average rate of change from -2 to 0. So from right there to right there, I'm going to have 5 minus 15 over 0 minus -2. I always have students, they'll say, well, I did 15 minus 5 and -2 minus 0, and I got the same answer. Yes, you did, and that's fine. You can start with the other point as your, x1, y1, and the other one can be x2, y2. That's fine, as long as you go the same direction. So, if you're calling these all your x1, y1 as opposed to x2, y2, this one just needs to be x2, y2, and just make sure you plug it in the formula the correct way. So that would be -10 up top. That would be +2. I think you're going to get -5 right there as your average rate of change or your slope. We'll see average rate of change of x over the interval -1 to 2. I'm going to look right here and right here. So -1 to 2. I'm going to say my slope or average rate of change is 3 minus 9 over 2 minus -1. That's -6 up top. That's +3 on the bottom. I think that is -2. -2. And is this function linear? I don't think so. If this thing were linear, all of these on the left side, this goes up by 1, up by 1, up by 1, up. So we would need to be climbing by the same amount or falling by the same amount. So this one goes -6, -4, -2. It's the same thing. So it's not going to be linear because your average rate of change is not the same between each of those. Next one, I've got from 0 to 2, average rate of change or slope. So I've got from 0 to 2, that would be 33 minus 17 over 2 minus 0. I think that is 8. The next one from -2 to 1, so from that one to that one, would be 25 minus 1 over 1 minus -2. That's 24 over +. I think that's 8 as well. And that's going to kind of send a signal out that I think that might be linear because we're going to be adding the same thing. So let's check. All the stuff on the left, that's going up by 1. Right here, I'm going up by 8, 8, 8, 8. So it looks like it's going to be linear. Yes, that thing is linear. I gave you a quadratic function right here and looking to find the average rate of change between 2 points. So same kind of ordeal. A lot of people, just like counting. That's probably the easiest, but a lot of people like writing the points out and doing the exact same thing that we just did. So from 1 to 3, so in x, this is my x-axis right here. So from 1 to 3, there's the point 1 right there on the x-axis. So there's my point on the graph. And then on 3, that would be right there on the x-axis. So my graph 3 is right there. Those 2 points would be 1, -4, and 3, 6. So if I'm finding the average rate of change, I would say 6 minus -4 over 3 minus 1. That's 10 over 2. That'd be 5. So let's check. Let's look at the graph, rise over run. I went rise 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I ran 1, 2. That'd be 10 over 2, which is 5. That one works. From -4 to -3. So -4, there's -4 right there. So my point on my graph at -4 is right there. The point on my graph at -3 is on the x-axis right there. Those 2 points would be -4, 6 and -3, 0. So I could punch that into my slope formula, which is the same thing as average rate of change. That would be 0 minus 6 over -3 minus -4. And I think that is -6. So let's check. It's going to be a negative slope, go down 1, 2, 3, 4, 5, 6. And over 1, that would be -6 over 1. Doesn't matter what kind of graph you got, do the same thing. Find the 2 points, plug them into your slope formula.